We're going to work with a few examples of finding slope on a graph, but this time those graphs are going to look a little bit different. So here is our graph of our line, and we are asked to find the slope of this line. Now we know that the slope equals the rise over the run. That's what we're used to using when we see a line that's graphed. Well, I have 2 points, and I know these points' location. So let me go ahead and draw the triangle that connects them. So it looks like something like that, right? Okay, now the problem comes when I go to count the rise and count the run. That's a little hard because I don't have any lines over here to tell me how long or how far to count. So that's a problem, but it can be solved because they tell me where these points are at. So this rise, remember, corresponds with movement along the y-axis. So in each of these points, remember the first number represents an x value, the second number represents a y value. In each of these points, I'm just looking at the y value for the rise. So in this point, I went from 1 up to 3. Okay, so I went from 1 to 3. Okay, how long is that line then if it went from 1 to 3? Well, to find a distance, I would just subtract. I would do 3 minus 1, and that means this line is 2. So my rise is 2. Now let's use a different color. Let's look at the run. So this distance right here. So once again, there aren't tick marks down here for me to count how long this is, but I do have x coordinates. And if I move left or right, that's talking about x movement. So let's look at our x coordinates. I went from 1 to 3. So this point was at 1, and this point is at 3. So from 1 to 3, I need to know the length from 1 to 3. And in order to find distance, I just subtract. So I'm going to subtract 3 minus 1. That means this length is 2 as well. So I did 3 minus 1 to find this length, and that is 2. So my slope, without using grid lines, I found was 2 over 2, which simplifies to be 1. Okay, let's do one more example like this, so hopefully you can see a pattern that's showing up. Okay, so I have my point C and I have my point D, but I don't have any grid lines. So let's first draw the triangle that connects them. And I need to know the rise, how long this line is, and the run, how long this line is. So I'm going to write that over here. So let's look at the rise. Now once again, remember the rise is talking about movement in the y direction. So in my points, I'm just focused on these y values. Okay, so this point, the y value is at 2, and this point, the y value is at 8. So to find this length, this distance right here, I'm going to subtract 8 minus 2. So that means 8 minus 2 is 6. So that means this length right here is 6. Okay, let's do the same thing now for the run. Different color now. So the run is corresponding with movement in the x direction. So I'm going to be looking at the x coordinate in my points. So point C starts at 1, and point D is at 4. So this length right here is how long this is. So to figure out this distance, I'm going to subtract 4 minus 1. And 4 minus 1 is 1, 2, 3. 4 minus 1 is 3. So in my rise over my run, I have 6 over 3, which simplifies to be 2. So without having any grid lines, I know that the slope of this line is 2. But we had to play around with the formula a little bit, right? Looks like we were subtracting the y values and we were subtracting the x values. And so that's going to be the rough formula that we're working with as we're going to be trying to find the slope when we're just given points, not a graph. So let's work with this equation now for the slope. We subtract the y values and we subtract the x values now to find the slope.